It looks like fly ash. This is grey-black fly ash. This is, carbon, but not much. So later on also, if you can get rid of the carbon, this becomes like talcum powder. Look like talcum powder, yes. It can particle size. Yes. Okay. I'll go back to the earlier slides, which I'll show in my next lectures. You will see the particle size of. All right. You can have different. The ones which you showed, one fly ash had about 100 micron particle size, but the rest of the fly ash had particle size about 10 to 15 microns.
One you have mentioned there is 45 microns.
45 microns, so those which are 10 to 15 microns, they are much useful. It is generally spherical, but there are some which are little bit spherical, little bit. Some are there, but about 80 to 85% of the fly ash is yes, because it comes out and then it forms very quickly. It's just condensed, and then it forms very good. But
reinforced material, this fly ash can be used as a reinforcement.
that's what you can use it as a reinforced material. Yes. Even if you put it in concrete, it's reinforcing in concrete. And that's what a lot of work which I will show there. We have done a lot of work by using fly ash in making composites, polymer composites. Yes. Yes.
No extra requirement of
No, this is directly from. Yes. Okay, so that slide which was there, that was the last slide for the lecture 5, 6. Now we are 4 and 5. Now we are going to lecture 6. So we have covered fair amount of cement, concrete, and how fly ash can improve cement and concrete. Now we are going to see how fly ash can be used in making structural things. And when you say structural building, parts of buildings, bricks are the important things, all right? And bricks have the advantage that you can condense the bricks, you can heat the things, and so I've seen some brick manufacturing places, all right? Use of fly ash in making bricks for constructions. Bricks are vital parts of structure making. Usually, bricks used in buildings are made of clay. Clay is mixed with sand and then dried, fired, and again dried. So normally, I found the place I grew up in India is on the river Ganges. So for example, if this is the river Ganges and this is our garden boundary, so we used to stand and you can see that. And even when big rains and things like that, sometimes some of the fish used to come inside our garden. So I said, hang on, go, otherwise they'll catch you and eat you. Okay, so I used to send them away, push them away. Now, but why I said that, and if we walked about 2 miles along the roadside towards the north, there are brick factories. They get clay from the Ganges side, okay? So they just dig it up. They don't have to bring clay from all other parts. And in India there are so many rivers, so that can be useful. So, and I used to go and watch the brick making. And when it started, the brick started, it had a clay color, but after the bricks are made, it changes the color. So clay is mixed with sand and then dried, fired, and again dried. That's how bricks are made. Sometimes shale is also added to the mixture of clay and sand. Initially, sand and shale are grinded, then mixed with clay in dry conditions. The well-mixed mixture with small amount of water is poured into mold to give a shape. So that's what bricks are done. So they are molds. So you make them and then mold and then compaction. So compaction mold, okay? And then you remove them from the mold and then you heat them. Shape and size of the mold depend on the dimensions of the bricks required. So you can have bricks different types. So for example, when you are walking, when I walk along the streets there, you'll have small all these pavers. They are also kinds of bricks. But they are a small hexagonal shape, all right? So bricks, you can make all different size, all right? After the mixture adopts mold shape and acquires some green strength, it is removed from the mold. What is green strength? What does it mean by green strength? Is it high or low? How many of you think green strength is high? Raise your hand. How many of you think green strength is low? Raise your hand. Okay, we have green strength. Green strength means before it is heated and cured. So it's just so, but it has to some strength, because if you take it out and it should not change its shape when you are putting it before drying. Okay, so green strength means it is not dried or anything like that, but it is the beginning of it, and then that becomes transferred into brick when you heat it. Okay, so it has to have a compaction. It actually has to have much less voids. The strength becomes more if the voids are less. So this is called as green unit, which is then kept in the atmosphere to dry up for approximately 7 days. Why you put it for 7 days? Because that way the moisture also goes out, so it becomes more dry. Because if you have more moisture, then when you put heat, you need to put more heating, and also there are more voids. And being in the area there, there's sun there, okay, and there is wind there, so 7 days is the time. Subsequently, it is subjected to firing to give high strength to the bricks and remove the water content. So that's how the bricks are made. Now the firing takes minimum 1 day or a maximum of 7 days. The temperature required is in between 1000 to 1300 degrees. So that's a lot of energy also. So remember, for every brick you have in these houses, it takes up so much of energy. And all that energy goes into the atmosphere. Now the natural color of bricks is reddish. Although where I put is reddish is not, I've not given the red color, but I just highlighted it in, okay? It's reddish, the natural color of bricks. But if you put chemicals in mixture before firing, you can obtain different color of bricks, which is from the customer point of view an attractive parameter. Because if you want to have bricks, orange color bricks, or other even blue color bricks, it's up to you, okay? But you can do that. But if you don't use any coloring agent, then the bricks not naturally are reddish. Particle size about maybe, depending on the table which I had showed you, those 4 flyers from Brisbane, one of them had particle size around 100 microns. All the others had particle size below 15, 12 or 15. Yes. This one may be about 30-ish or something like that. Texture is another aspect of bricks that is of important. Texture means, so where we live in Sydney, we have a small house and it's made of brick, but they don't paint any color on the brick. In India, most of the houses which are painted, but there, unpainted bricks look much better, because if you have painted bricks, after some time the paint gets scratched and things like that, and it's very expensive. Here, if you want to make a brick wall, a small thing, how much money you have to give it to the person who do them per day? 500 rupees? Okay. So there, the same work, you have to give $500 to $1,000.
That's why they use the kind of wallpaper inside their houses.
Wallpaper is not for that. Wallpaper is something to make it look nice and things like that.
So you're talking about the outside?
The outside. Say outside, no painting. Some people do it, but it looks nice, but they also are very conscious about how it looks like. Okay? So they make the texture very colorful. That's what I was going to say. Like what they say, the texture, how it looks. Texture is beautiful. So about 60 to 75% of the brick houses have like that, okay? No painting and things, but they look very nice. The texture is very good, okay? Facing bricks have attractive colors and textures so that it can be used without rendering, plastering, or any other surface treatment. So that's the kind of thing which we are saying, okay? So recently we did we made a small renovation, but again, the people try to find out similar color brick, matching bricks, so just put it on. So we didn't do any painting. But some houses, they do the paint, and the paint after some time, the paint cracks, because if the brick condenser expands or contracts, okay, when heat and cool comes, then the paint.
Some of the cracks may occur.
Yes, like that. Most of the people try to do their own painting, okay?
But it's costly.
Yes, it's extremely costly. But sometimes I look at it the other way, like people who do the painting, they also need jobs. So I look at from their point of view. Yes. All right? So it has both sides, because then at least if they get the money, they have their family and things like that. All right? But what I'm saying is that sometimes people think $1 is worth like Australian dollar 50, but when it comes to work and other things, there is no difference. $1 and 1 rupee, there is no difference. That's what. At least in Australia. In America, it is slightly different. America is much cheaper. But I don't mind, because the people who do that, and they do good work. And to me, they're like part of my family, so they do the work. But that's what I'm saying, that if there are cracks and things, all right? But if you're an engineer or if you're working that area, you have to keep all these things in mind. And if you need when you're doing a business, if you need information, always hire a good chemist. Okay? Because chemists can help you. Facing bricks have attractive color and texture so that they can render plastering. Rendering means like kind of painting and things like that. All right. Or any other surface treatment. Other properties that decide quality of bricks are absorption capacity, initial rate of absorption, modulus of rupture. Modulus of rupture means at what stress and at what point rupture means the collapse, breaks down, all right? Yes, because sometimes if you have brick walls and when people are working there, if it ruptures, it does rupture. And wall falls on the people. So that is, and they,
That causes fatality.
huh?
That causes fatality.
They just die on the spot and no one can do anything. And it doesn't get any time. So that is the kind of thing. So you should have bricks which should not fracture. You should have more toughness. All right? Something like that. And brick is something, once you see the crack coming, if it comes like that, it goes through the cement and the crack continues because it's a brittle crack. But if you can make the brick a bit ductile, then the crack will not be a sharp crack. It will be a rounded thing. The chances of cracking or breaking is, yes. And anywhere, I remember about 15, 20 years ago, in Gujarat, there was a huge earthquake. Remember? And so many buildings collapsed. It happens in Mumbai. Even it happened in Kolkata about 3-4 years ago. So that is another aspect of research, but I thought I'll mention that. We have done a lot of work where we actually have used carbon epoxy composites, give coating outside the brick walls because they take up energy. Whereas bricks takes very little energy. The carbon epoxy composites, if you give that, it can survive the bricks. It can hold the bricks for at least 10 or 15 minutes, even under very high this cyclone or earthquake. So that gives a lot of stability. If there is earthquake or if something like that, you can, if you have 10 minutes time, you can run out, at least go outside. Okay. And that is first started when many years ago in California, under the earthquake, some of these roads, they all collapsed and killed a lot of people and then they came up with this idea. And the composites people say, yes, use the concrete, but also use fiber reinforced things there. So they are much more tough. And the bridges also, the structure is much lighter. Okay, so these are all the advantages. Now you may ask, how is fly ashing? When you are using composites, you are using epoxy, for example, and then you are putting fibers or fabrics. But you can make, epoxy is brittle unless you are using rubber toughened epoxy, which I did work a long time ago. But if you can put some small particles like short milled carbon fiber or even fly ash particles in the epoxy, that can make the epoxy tougher and stronger. If the epoxy does not crack, then the crack will not propagate through the things. Okay, so those are the areas you can make even composite structures. You can make them tougher and better and also cheaper by using fly ash to improve the epoxy matrix. Okay, that's to answer your question. As I may have mentioned about in 2016, United States Innovation event, they do that military defense innovation, and they invite people from all over the countries to submit their work, and we had submitted a paper which we had published in an international journal of Building and Construction Materials, and then they accepted it. And there we actually we toughened the epoxy with short milled carbon fiber, very cheap, and it gives much better strength. But before I went to make my presentation, I sent that published paper to a professor in MIT, whom I had met some 25 years ago. And at the time he appreciated my rubber toughened epoxy work because he had said that 25 years ago, he said that you are the only person from the entire world, you have come from Australia, and you are showing us how the toughening goes through. We did inside SEM, in situ scanning under microscope crack propagation studies. We presented that. So I remembered that, and then 2 years ago when I was invited, then I sent that paper. I said, Professor Argan, I had met you about 25 years ago in Washington, D.C. in a conference, and now this is something else we are doing, and United States Defense Innovation has invited me to. So before I accept there, do you think this is worthwhile? Because I wanted his opinion, okay? But I don't like saying that yes, this is good. Only when other people, experts say that it's accepted, then I. And then immediately, within 24 hours, he said, yes, Bandy, please go ahead with it. Go a presentation, accept the invitation to have a 3-hour table. So on the top of the paper, I included his comments. And then I put, because that is high respect to that man. A.S. Argan, A-R-G-O-M. He is now a honorary professor. But that is how things happen. Next thing you can do that, instead of putting the short mill carbon fiber, you can put fly ash. And it will be inside the structure, so there is no pollution and any other thing will come up, okay? That's how things will come up, all right? Now, one thing in India has one advantage. If you want to make new industry, it is much more affordable because the companies can afford it there. Whereas in Australia, new industries often move away from Australia. They are going to other countries because the industries, they cannot make new products. It's very expensive. Except the mining industry. You cannot take minerals to another country, all right, unless you do that. So in India, it is much more affordable. So I suggest you guys react and interact with industry people, and then you can export these things to outside. And fly ash is capable of improving the properties. Okay, quality of bricks, absorption capacity, initial rate of absorption, modulus of rupture, bond strength, and durability. Bond strength means between the different elements of the brick, all right? To ensure safety, now fly ash should perform its work properly, and thus some standards are assigned that must be followed by brick manufacturers. So if you are thinking of making bricks out of fly ash, no clay, nothing. So now we are talking about fly ash bricks. So you don't have to do it next to the river Ganges or next to the river Jamuna. Is Jamuna close by? Jamuna, इधर तो गैंजेस है ना गंगा. होली आ रहा है ना, होली वो एक गाना है ना, ये होली, हाँ भूल गया. लीला करे श्री हरि मधुबन में श्याम बिहारी खेले होरी, गोपियों के बीच श्री राधिका संग, लीला करे श्री हरि मधुबन में श्याम बिहारी खेले होरी. वो तो दिन आएगा ना. अच्छा, इसलिए मैं जमुना के, हम जमुना गए थे, हम वृंदावन में गए थे, तो जमुना किनारे हम बैठ के बहुत सुंदर जगह है. Okay, so if you are making bricks out of fly ash, so we have to think of what fly ash is and how it can do. But fly ash has all the ceramics in there. That's the big advantage, okay? And at high temperature, how things are done is called sintering of ceramics. Remember that? Sintering of ceramics. And as I said, like Chris Sorrell, Charles Sorrell, so he's a good friend of mine. Whenever I have difficulty, and he's a very nice man. If someone ever comes against me, he will go and hit him on the nose. So don't be bad to Bando. Thank you. But he's a wonderful person. But any of you are interested in finding even some short-term things, or even 1 month, or you can say that, sir, I would like to learn from you and do some work. Get funds and things like that. You can write, and you can mention my name. Dr. Bando has suggested. All right. But sometimes when he's in his office, if he's unhappy, he keeps on shouting. Everyone runs away. He shouts so much to himself. He's the only one who does that. But then when I pass through his office, I know that that's Chris Sorrell. He's a wonderful man, wonderful son. Charles, he calls C.C. Sorrell, Charles Christopher Sorrell. So I had given that. Yes, yes. And Dr. Pramod Kochi is now working with him. Pramod Kochi is from Kerala, but he did his PhD there, and now he's working with him he's a very nice man too. Contributions by India. Now, India has done a lot of work in fly ash research, and I thought it will be wonderful if I can highlight India's work, because India is a leading country in fly ash, and also because here it is much easier to manufacture things, okay, because cost effective, and then you can export these things there. All right. To face disposal problems of fly ash, many countries are carrying out research to use fly ash in bricks. And what you need, best way, wherever you have this power plants, if you can get some space close to it, you can get the fly ash directly from there to your brick manufacturing place. You don't have to take it to other places through transport. Pioneering study in this area was done in India at R&D of National Thermal Power Corporation Limited. So you can look it up. And their study proved that fly ash, lime, gypsum altogether could form a building brick which satisfied the parameters requirement for building a structure. An autoclave was used to form bricks at a pressure of 23.5 MPa. Now, in that research, the finished product shows high water absorption and low fire resistance. So, finally, they kept on doing more work, and further study using high pressure molding shows more satisfactory outcome. This is the thing. This work was present in Chicago. D. Kumar S. Kapoor, okay, 1996, about 20 years ago. Any of you know them? But you can find it out, all right? In another study, again, Indian study, Sloankar proved that using 72% fly ash, class A fly ash, and 25% bottom ash. We have given this bottom ash also composition in one of the earlier slides yesterday, and remaining 3% sodium silicate could achieve required commercial specification. So that is the way research goes. You do something, you get something good, but it needs to be better, and that's what research does. In 1992, India produced useful calcium silicate type bricks by using fly ash. And then also in Australia, a study in my university, UNSW, but he's actually a part of the Australian Defence Force Academy in Canberra, which is part of our university. So over the Kaili, he produced bricks using 100% fly ash, and the results were highly satisfactory. And this is that website. And I'll show you in one of the tutorials, I'll show you what work they did, okay? Because today, in the after lunch, we'll have a tutorial so that we can all take part and things like that. And I think I have included his paper, is that a tutorial. But you can write down this website, HTTP. Just take 10 seconds. It's very simple. /www.flyash.info/ single slash 205, single slash 5, K, I think that K stands for Kayali. Yes. .pdf. And this work was, this one has been commercialized, this work. Yes, but yes, and it has been patented. So if you go there, and what happened in China, they showed that there are huge buildings. They are using bricks made. Yes. Well, cost of the brick. If you make in Australia, it will be very expensive. But if you make in China, it will be much cheaper. If you make in India, it will be very possible. Well, clay bricks, as we have gone through there, see, it takes a lot of energy and things like that. So where if you use fly ash bricks, it takes a lot less thermal energy. So
We are seeing that a pressure is also required in fly ash.
no, pressure is required in any type of work. So you actually put the things together, you have to bring into the form, and you have to do the pressure. So pressure is always required, sintering under pressure. That is the standard thing of. Yes, but clay is another thing. Okay, let me put it this way. Yes, not only that, the clay, what happens, if you use too much of clay, there will be a lot more floods in the rivers. Because all the clays, that means yes, whereas you have fly ash, it has all the qualities. Why do you dump it in water? And do it in India and export you. But that's what, there is if you go to that, I think you can see a 2-minute video which our university showed there. So there, this Kylie, you can find this, I think, I don't know whether he is Australian or whether he is European person there, but he has done it, and they also show in China, huge building is using these flash bricks. And flash bricks are also lighter. Okay? But thanks for asking the question. All right.
And you mentioned autoclaving. You maybe hide autoclaving because I have seen that in Odisha, in fly ash brick they are mixing fly ash, lime, and gypsum, and put the mixture in a mold and demold it, and they are allowed to dry it after a certain day.
After 7 days, okay.
To use it. So autoclaving method is generally used first means steam. So
Actually, if you do not use this sintering or autoclaving, the strength is not high. The normal thing, but for some things like if you are using this as pavers and things like that, you don't need that high strength. Okay? But if you make a building structure, the lighter it is and the stronger it is better. So these are all the aspects. But it's a good question. Always it's good to have question. And Bhubaneswar have a lot of fly ash bricks, is it? Okay. So make sure you visit one of the Bhubaneswar brick factory.
Clays are not allowed.
In Bhubaneswar.
Fly ash is more number of welding structures.
Then it is allowed.
Bhubaneswar में what? Kathak Mahanadi. Mahanadi. So they used to use the clay from the Mahanadi, is it? Now they are not allowed. Okay. Thank you. So it's good that all these questions are coming up, because that is wonderful, because then answers also come up, all right? And as I mentioned, yes? Can you speak up, John? Hybrid? Yes, you can make hybrid. Hybrid means mixing. Yes. In your state, do you have hybrid bricks? Yes. Yes, concrete is also now becoming structure. Yes, but in the concrete, they can use fly ash also. In this fly ash you can use, because concrete is much heavy. So if you can use some fly ash, then it can give the strength and the toughness, okay, and it can make it lighter. Yes. Fly ash is a very usable thing, but depends on what kind of applications. Fly ash bricks don't look very, very beautiful. Okay, fly ash bricks don't look very beautiful. It looks like me, all right. So just very clumsy looking thing. Fly ash bricks look like me, so something like that. But in the China, that building which our UNSW professors, this fly ash bricks, they're developing each other. But it's big building, and then ultimately you can paint or do other things. Okay, but it's much lighter. Because lighter structure is again very good in case there is any earthquake and things like that. If it falls or breaks or people, it will be much less dangerous. Okay, so fly ash bricks. So this Australian 100% fly ash bricks. So maybe when you have some time today on your computer, you can have a look at that thing. It's a 2 to 3 minutes video, all right? And you can have a look at that. Now, in the following section, use of fly ash in making brick is divided into two parts. Using fly ash with sand or clay, and B, using 100% fly ash. So that's, I think, that's what you were saying. So whether you can go for 100% fly ash bricks, yes, we can actually make, like that first part of yours, that can you mix the things together? Yes, you can go either way. If you use part clay and part fly ash, clay has a lot of good properties, but clay is a bit heavy, so you can maintain that. But if you are do not want to have that heaviness and the things, and who cares about clay, all right, then you can use fly ash. The fly ash is hugely available. What attracts fly ash to be used in clay bricks? That means you can put fly ash in clay. Before studying how fly ash is beneficial in making bricks, it is worth examining the physicochemical similarities between clay brick, conventional bricks, and fly ash. Now, this is, you are now going to the usability. For comparison, fly ash can have a density of 2, which was taken from this thermal power plant, and clay bricks with a density of 2.61 was taken from a big factory in Turkey. So this is something now we have gone through India, now we are going to Turkey. Turkey is also quite an active country, okay? All right. And then they produced This is table 11, fly ash and the brick, fly ash brick and the clay brick containing fly ash. Okay, they contain the same chemical components in very similar ranges, except the loss on ignition value percent. So here you will find that in fly ash bricks, so you have these things. The percentage is not much different. Clay brick. But if you are going onto the clay brick, the loss on ignition is about 8%, whereas in fly ash brick it's about 2 to 2.5%. So that is the main difference. Okay, and if you have more LOI, it can give more difficulties. But as I said, that American standard said that an N-type fly ash, it has about LOI about 10%, whereas the C-type and F-type fly ash have LOI about 5%. So this is the source of information, and it is what comparing these values. Another study proved that large CaO content can help to scum deposition, which is an undesired feature, and there is a level up to which CaO can be allowed in bricks without scum formation. So you can use calcium oxide if you have calcium oxide in the brick components, up to a certain percent is good. And then if you look at the calcium oxide content in fly ash is far less than maximum allowed level, which is a great advantage of fly ash. So fly ash has much less amount of calcium oxide. So that way, if you use fly ash as a component of the brick or fly ash bricks, okay. I did not know that Orisa has prevented clay brick, okay. All right, that's good. So please send me some information, I'll go through that, all right. Any other state has prevented making clay bricks in India? No? We had, I may not have mentioned, the Chief Minister of Chhattisgarh, Dr. Raman Singh, he and his team went to Sydney about a month ago, and I had a chance to talk with him briefly, and his management and secretaries, they are very interested in fly ash recycling. So maybe sometimes in future when I come, I may have to go there. And they said that they have the 25%, total 25% of electricity or something like that, which is the highest in India. They said, but they were very interested in fly ash, and I can now see that Odisha is also very active in fly ash. Okay, so maybe next time you can request your Odisha Chief Minister to come there, because that way we can interact. Okay, and I'll try to come later on when I come, but we need to work together, or you can work with Chhattisgarh and something like that, if you wish. All right? As fly ash sample is made up of most spherical particles. Yes, you are asking, your question was, is fly ash spherical, or your question was that, Dr. Arpita? Yes, it's made of mostly spherical particles, whereas shell particles are flat, so fly ash is much better than shell particles. I think there is a figure. B is fly ash. Would you call it spherical? And this is shell particles, okay? So A is CPSI bonded, and this is fly ash and sample ash, okay. This is the source given there. So fly ash has spherical particles, but sometimes the spherical particles have voids inside that. So that is what noting it. Because if they have voids, and sometimes the fly ash can crack it, okay? But that's a different aspect. But it is worth knowing that if spherical, they are not always solid. Porous, yes. Bricks made up of clay and fly ash to find out the effect of fly ash on properties of bricks. Many experiments have been reported on studying brick samples with different fly ash content. And for example, Tutunlu and Atale, they manufactured fly ash bricks with 40, 50, and 60% fly ash and compared the properties with 100% clay bricks. And all the bricks were made under the same conditions, such as pressure of 300 kilojoules per centimeter square, which is what 29 MPa, dried in open atmosphere for 3 days, and fired in a metallurgical furnace at 750 C, 850 C, and 950 C for 1 hour. The results obtained in this research were not so satisfactory. However, they proved that fly ash can be used as an alternative for clay brick manufacturing, and it just satisfied the required standards. So they attempted different content fly ash in bricks. So using clay and fly ash bricks sometimes is useful because sometimes manufacturers can do that, but it's the people's choice. Because if you have fly ash heavily available and cheap, you can go for that. But clay has some good properties, like, as I said, I grew up on the bank of the river Ganges, and when I used to go and take bath, we did not have any shower or anything at home, so we had to go and swim in the Ganges. Okay, and on the side clay thana, so you put your foot, you can feel how thick, not only soft but how thick it is. Clay is very, very thick. So I love clay. So if all the clay is used in making brick, I don't like it. So go and use fly ash. Okay, so the compressive strength and temperature on this side, okay? So the 100% clay bricks have the highest strength and temperature. 40 or 50% clay, 50% fly ash clay bricks do not have that much compressive strength. But that's what they showed, that if you are using fly ash, the strength may go down. For example, the compressive strength of fly ash brick was significantly less than that of clay bricks, but it passed the ASTM standard of concrete, which means according to the ASTM standard, these values are acceptable, but these values are much better. It is possible that a more suitable test method could be used, such as the 3-point bend. You are familiar with 3-point bend? What is the tensile strength or compression strength is putting like that. Tensile you are pulling like that. And 3-point bend is, you have like this. 3-point, come here, show your, okay. Okay, you put your hand, I put my hand here, and you push it from the top. Come on. So I'm giving this, in the middle you put it in. Push, push. So it is bending towards, okay, so this is, can everyone see? Okay, you can. So this is the supporting, okay, and this is pushing there. So that is the 3-point bend. The 3-point, thank you. Advantage of 3-point bend is that particularly with brittle materials, you get much better property. Because there is no crack generation, so it's bending, so 3-point bend is a much better technique. And particularly with composites also and things like that, okay? So please keep that in mind. Huh?
Flexibility.
Flexural strength.
Flexural strength.
Yeah, but it's a kind of flexural strength, so it gives the deformation, but you see how much strength, how much stress or load it can take before it cracks. And also, if you are using specimens with a notch and a sharp crack in there, that thing, you can actually also measure the fracture toughness. 3-point. Bricks made up of 100% fly ash. Australia, this is as I mentioned. Obada Kylie from University of New South Wales, Australia, did the most successful study in the use of fly ash in building bricks, using 100% fly ash. And these bricks, known as flash bricks, proved better than clay bricks, as described in the sections below, showing many advantages over clay bricks during manufacturing and performing under required working conditions. So I'm proud that my university, and also he's working in Canberra, we are in Sydney, but it's from civil engineering department. So, but my university part, I did not know him, so I have not interacted with him. So they have done it in their own way. Methods used for manufacturing flash bricks. Flash means fly ash bricks. That's what they do in Australia. If your name, what is your name? Prajwal. Prajwal, they will not call you Prajwal. They say, hey, Pro. They say, Pro bolega. What is your name?
Yes.
Yes. Yeah. What is your name? Bob. You will be Bob. My name is Bandobadai Bando. Okay? What's your name? Arpita, Arp. Like their name is David, they will not even say David. They say, hi, Dave. Okay? So that's how. So if you have fly ash bricks, why fly ash? Just flash. So once fly ash, no, flash. But I thought fly ash would sound more technical, but they are Australian. They say, no, fly ash, it takes quarter of a second more. I love Australia. Okay. So the advantage of flash bricks, the main advantage of flash bricks is that they are eco-friendly. That means they are environmentally acceptable. Okay? And processing features as listed below. In case of flash bricks, the factory location can be set anywhere near to a coal power station, generating fly ash on a regular basis. The raw material preparation advantage is raw material is readily available at power plant station in large amount. Raw material does not need any pre-processing such as grinding. Raw materials in fly ash are just fly ash and water, which get quickly and easily mixed together. So you have everything ready. And the quality of the raw material, quality of fly ash from power point is pretty consistent because you are using the same type of coal. Okay? But if you are changing the coal, then flows. But normally, they use a similar type of coal for many years. Quantity of raw material required for the formation of 1,000 clay bricks is around 4 to 5 tons of clay and shell, whereas 2.75 tons of fly ash is required for making 1,000 flash bricks of the same dimensions, which are lighter weight. So can you see that? So you get 1,000 flash bricks of the same dimensions, but they are much lighter. So if you have to 4.74, so let's say from 4, if it goes down to 2.75, you are saying about 30-35% around weight. So that is very useful, particularly transferring and things like that. And people can use in their own countries, they can actually manufacture the things. Process parameters on clay bricks and flash bricks. Time. Grain unit formed by clay and shell takes about 7 days, whereas grain unit of fly ash and water takes only 24 hours to solidify. But it can be kept up to 3 days. So the time required to initiation of the process becomes about in the 15% only of the clay bricks. But sometimes if you want to make sure that you can go up to about 40 or 45% of the time. So you are saving the times. Temperature, a temperature range of 1000 to 1008 is required to bake both grain units. But grain unit of clay and shell requires an average 3.5 hours, whereas 3.5 days, whereas the flash and things, to make flash bricks, it will take less than 24 hours of firing to attempt. So we are saving a lot of time and a lot of energy. test results of flash bricks performance. So these are other things given there. Modulus of rupture, then clay bricks from less than 1 MPa to greater than 2 MPa. So they are comparable. Now modulus of rupture means because clay bricks are much more solid, that's why their modulus of rupture is a bit more. But fly ash bricks, it shows 0.8 MPa, which is slightly less than that, but also it must be fitting the ASTM standards, things like that. Okay. Flash brick, this is clay bricks, but if you make flash brick, this is Australian standard, 0.8. But if you make flash bricks, you are getting about 4.3. So here the standard is 0.8. Clay bricks is strength is 12 to 40 MPa, but flash bricks is much less strength, at about 4.3. And sample of best clay bricks in Australia has 34.5. So clay bricks can give you much more higher strength. The other modulus of rupture, fly ash flash bricks is about 10.3, which is better than the sample of clay bricks. So these are the other things. Average density. So this is another website. This is another website for the flash brick, okay? Compressive strength, as per the Australian standard, the minimum acceptable limit of compressive strength for building bricks is 7 MPa. Typical compressive strength of clay bricks range from 12 to 40 MPa, and that of flash bricks is about 43 MPa. So that's fantastic. As claimed by the researcher, the compressive strength of flash bricks is about 24% better than compressive strength of the best clay brick available in the Australian market. So that's how they had to prove. In table 12, tensile strength is expressed in terms of modulus of rupture. This properties of flash bricks is found to be about 3 times better than that of the best clay bricks. So this was considered as the best achievement of flash bricks, which explains why much less cracking is observed in flash bricks compared to clay bricks. Cracking in bricks may be because of differential settlement, excessive tensile natural loading. Tensile natural loading is when you have a brick wall, there is tremendous amount of force coming up. The lower thing has many more things, okay? That's why often you will find that there are cracks in the lower part of the bricks and things because it cannot take. Yes. Even the hostel where we are staying, when you go up, I can see near the bottom of the staircase, not the bricks, but in the concrete structure, there is more crack because the load there is so high. Yes. This is a major construction. Okay. Cracking in bricks may be because of differential settlement, excessive tensile natural loading, salt crystal growth or freezing or thawing. This is a major consideration in construction of, and flash brick gives better results. Density, the density of flash bricks is 0.75 times of the clay bricks. This advantage of low density of flash brick allow more loading flows, ease of transportation, and construction with low transportation cost. Also, the weight of raw materials that would produce 265 flash bricks can make clay bricks that can make about another 100 flash bricks of the same dimensions. How many? Okay, I have only 3 more slides, so I'll finish it up. High initial rate of absorption and subsequent steady absorption rate. Now, strength of the structure mainly depends on the bonds between the bricks and the mortar, and this bond depends upon initial rate of absorption and the steady state absorption rate of water and things like that. If the initial rate of absorption is very high, bricks absorb water immediately from mortar and become dry and weaken their bonds. On the other hand, if the initial rate of absorption is very low, bricks don't absorb excess moisture in the mortar, between the bricks of the mortar. In the same manner, absorption rate also affects strength and durability of the structure. If absorption rate is very low, rainwater runs to cracks and weakens the structure. So that is something, that means if the bricks cannot absorb the water, then rainwater runs through the cracks and gets absorbed there and weakens the structure. So again, fracture mechanics become involved. And if absorption rate is high, if absorption rate is high, then volume changes occurs and creates cracks. So absorption rate actually affects all the properties. The absorption rate and initial rate of absorption should be in the optimum range, as table 12 suggests, that table. High area and absorption rate of flash bricks shows satisfactory results and improves strength and durability of structure. So if you are using 100% fly ash bricks, it can give you much better results. Mechanical bonds is the last sentence and the last slide with statement. Another type of bonding between brick and mortar is interlocking bonding. What is interlocking bonding? Any chemist professor can tell us? That means it does not allow anything more to come up, or it forms some. Yes? Lock and key, okay. That's good. Lock and key, that reminds me of my wife. She puts everything under lock and key so that I cannot take out, all right? Okay, but she's nice, because I might take some extra medicine and say, no medication. You don't have headache, you don't have to take any Panadol tablet, paracetamol, okay. But that means it protects, all right? It does not allow anything bad to go in, all right? I told my wife to come and sit here. I said, look, we have so many nice people in the floor. She said, oh, I get totally bored. I said, okay. Because I'm a boring person. I'll try to bring her one day. Is it all right? Thank you. But she is a wonderful singer. If she sings, half of you will think that she has voice similar to Lata Mangeshkar, and the other half will think that she has the singing voice of Srimati Asha Bhosle. All right? That's why I always bring her, because even if she hums and sings, so that gives me time to make all these slides. Now, we had shown in figure 11, microstructure A shows the cross-section of the flash bricks, and microstructure bricks shows its surface feature. So figure 12A shows less number of pores on the same. So this is what happens. Let's have a look at this. Oh, the A. So this is where you actually, figure 11 picture shows closed view texture of slice A, surface B of the flash bricks. Now it has given a scale bar. Okay, this is not SEM picture. I first thought SEM, but here they have given a scale bar. So most likely the scale is in millimeter. So this is, here you can see, all right, both of them are the same scale. So texture of slice, if you have taken a slice, and this is the surface on the thing. So this looks like, normally if you take a look at the bricks, some bricks have such minor voids and things like that. So flash bricks, they look like bricks. And they have better properties. Okay? With that, it's time to have lunch. So don't eat any fly ash during lunch. Okay? All right. Because we don't want to do that. But use fly ash and you get money to selling it, and that will help you have good lunch and dinner. We have just finished